Today, regarding Docker. Um, so first of all, where it fits in. Okay. Before we begin, you see that in DevOps environment, you have you start with source code management in the software development lifecycle. You start with the source code management, then look at build, and then test, and then release, and then deploy. Right? After that, of course, monitoring comes in. So during the deployment phase, okay, okay, so while you are creating an environment, okay, for deployment, right, you need to again add a lot many dependencies, packages, and all those things. We talked about it in Chef as well, how to create that environment, right? But Chef basically is more about configuration management, right? Which includes installation of the packages, installation of the configurations, all those things. Right? What Docker gives the whole you an isolated environment, right? So suppose you have say Livian Unix system, okay, but now you want to test out a particular application in say Red Hat Linux environment, right? So this using Docker, you can create an environment which is totally isolated. Isolated in the sense that it would not be disrupted by other processes or something which is running on the same system. Okay? And then it is going forward and see that what are the other features of Docker. But it evolved mainly because that it can give you a very isolated environment. You can run your application code only with bare minimum dependency. Okay. So when you have tested your product in such environment, then you can be sure that it will be running like this only wherever there is no content from other side, it is running good. Okay. So basically, see what happens when you are working in a organization. Then there is your client, and you are the one who's created the application, right? Now, during the acceptance of the product, there will be a lot of negotiations and that acceptance testing. Sometimes what happens is that on your end, acceptance testing happens and it is passed, right? But when you run the same thing on client server, it is failing. Okay, because maybe some of the packages which are installed on your server, right, where acceptance testing happens, it is not there on the client server, right? So I mean this looks a very small issue, but sometimes it creates a lot of delay, a lot of debugging, those kind of things. So if you test the, so for example, this acceptance testing only, you should do it in a very isolated environment where there is no interference. I mean, whatever is installed, you know what is installed, right? Then it can be very helpful. So for now, Docker are being used mainly for integration testing, testing. But it has the potential to go into the production, okay? Go into the live systems. Okay, but for now, since Docker is very new, okay, so it has not developed that much faith that it is. I mean, a lot of companies are using this in production systems, but on a mass scale, it is not came with that industry. Okay. So, before we will just cover this from these two slides, this definition, and then we'll come back on the slide. Okay, so Docker is basically open source platform to create, deploy, and manage virtualized application containers. Okay, on a common operating system. You will make a system of varieties. See, you may not get all the things that we're talking about here. It will come slowly. Okay. So basically, this isolated environment that I'm talking about here, that is basically called container. Okay. To explain it more, I'll go to another slide. Okay. For now, I just go through this. So Docker is basically, first of all, it's a company. Okay. Docker is a company that develop that has kind of monopoly in this container market. Okay. This container thing, this isolated environment thing, Docker was the first one who created these kind of applications, kind of containers. Now it is now a lot of companies are doing it. So it is a company that originally developed Docker. So there is one application called Docker. There is a company called Docker. So got it, right? So it supports commercial edition as well and principal source to the open source code. So though Docker is an open source, but there are commercial versions of Docker as well, where you get more features, more support from the official. It offers you the ability to isolate your application, one thing, standardize your build and deployment process, another thing, and create standard and repeatable process in your software infrastructure. Yes, that is basically what your Docker offers. So Docker and container sometimes they are used interchangeably. Okay. Say for example, you say that for photocopying a paper is called Xerox. But Xerox was the original company that started photocopying, right? So similarly, here, container is a technical term. Okay, Docker is the company that created for the first time this unique container. So container is exactly what you might expect to be based on the general definition of the word. It is entirely isolated set of packages. Okay, library and application which are completely independent from the surrounding. Okay, so we will exactly see why it happens. So, but to just give you exactly what it is in the real life, you can think of table, right? Now, your table may have dust, it may have some other articles kept on the same table, right? But you can put a plastic container over your table, and whatever you put in that container, that will be isolated from your surrounding, right? The same plastic container uh, is basically a container, right? If you think in terms of software, so your table is basically the operating system on which you are working, right? But when you are putting a container, it is isolating you from the table. So the base is still table. See, the container is kept on the table. That means the container is running on the operating system. But all other processes that are running on the same operating system, they will not affect anything which is running within your container. Okay. So this is why containers become so important for because of this isolation and also because of um, other features like it is very lightweight. You can create container, you can delete container in almost no time. Okay. So to explain exactly, see the conceptual part is more important here. Okay. Then of course we will be coming to the lab and we'll see how exactly to implement it. But for now, let's see what exactly were the challenges. Okay. Now here, see, you have to think a bit from developer's perspective as well, right? I mean the whole SDLC knowledge you need to use, right? So, what is the challenge of basically creating a product, testing a product, and then shipping the product to a particular client? Okay. First thing is there could be multiplicity of stacks. When I say stack, it means one thing. For example, static website is there. Now it would be using multiple technologies, right? So it may be using Nginx, then for security, more security, then encryption of necessary, then bootstrap for the framework, development framework, right? So it could be using all those things. If you have analytics database, which is another application, then you have all these various technologies, right? So basically, there are multiple technologies. Using all these technologies, you are creating a single product, right? So your product becomes very dependent on the various technology packages, right? Even each of these technology may be dependent on some other technology. So that is your multiplicity of stacks. Then do services and apps interact appropriately? So likewise, this you'll see here in Jenkins, right? You are just installing Jenkins. Now it was actually asking for Java 1.8 rather than 1.7. Okay, for that we have to remove Java 1.7. Now what happens if some of our application now demand Java 1.7 on the same server, right? So these kind of conflicts will appear because different services may want different thing and may interact differently. Okay, so that is another challenge. Now then, of course, on the hardware, this is we are talking about on software side of it. Now there is a side on hardware side as well. Okay, that is there could be multiple type of hardware environments. So it could be development virtual machine, it could be QA server, customer data center. All of these features of all of them could be very different. So sometimes it is running on the QA server, but it may not run on the actual data center. So that problem is there. And then when you are basically shipping it, right, when you are actually delivering it to the client, right, then can you migrate it smoothly, right? Because he would be maybe the application is very much data intensive, right? The client was using some old application with that data. Now, even when he is going to take a new application, but he still need that old data, right? So it should be very much smooth that all the data should be and connect to this. Okay, so these are the various real life challenges that you face in real product delivery. Okay, so if you so this is something called basically metrics from here. Okay, so on this and this side you have various kind of applications, and on this side you have various kind of hardware, so software side and hardware side. So which one to select? This will always be a perennial question that which for a static website, which technology I should choose for a development area, which one I should choose for QS. Right? So most of the time, a lot of your senior in technical management would be wondering about is that which is package, which dependency should I use so that it is more stable and more relevant to our application. So, a lot of time goes into this, right? This is called like metrics from hell. Now, to just give you an analogy, okay, because Docker is basically based on the term Docker is for based on the shipping, sea based transportation. Okay. So here we're giving an analogy that before 1960, okay, there were the similar challenges in terms of transportation of goods. Okay, so for example, you have some petroleum to transport, some say liquor. Okay, you have a car to transport. You have some explosive. You have some food grains to transport. Do the same thing. Okay, so you have to take care of everything. Everything has a different requirement. Maybe you cannot put this food grains alongside your petroleums, right? Because otherwise it will become a smelly, right? So all these things all these things are various kind of challenges similar to what we have in software delivery. It is there in the basic goods transportation as well, right? So multiplicity of goods in the multiplicity of stacks. Then do I worry about how goods interact with each other? Can I put this along with exclusive? Right? You have to think about that, right? Can I put this with along with this? Can I put this one along with this side? All these kind of challenges are there. Similarly, what when you have the good, how to transport it, right? All those various, you know, problems were there in implementing system. So here the matter from here looked like this. Okay. Now the solution was that they created something called intermodal shipping container. Okay. So these containers, you must have seen this in shipping industry, right? So what they did is they created a container, something like this, a very standard size, and all these goods they will put in the container. So in one container, only one type of good go. Okay, and this is airtight. This is basically so isolated that even if you put two containers, one including explosive and another having say tea, right? Then they won't I mean they won't interact with each other, right? So ultimately, what you are giving is you are giving isolated environment to each and every item. Okay, this is also good in terms of transportation and interoperability. The same container when you receive via ship, okay, you can put it on a just use the cranes and put it on the truck, right? It should be empty truck. Now this part becomes its solid, right? So you can store it like this only. You don't have to basically remove the item and put it again somewhere else, right? So and then you can use it railroads, you can use buses and trucks, whatever you want, right? So this is just this gives you one solution which removes all your basic challenges. Okay. So similarly, here also in software delivery, we created something called containers. Okay, and that is why this is so much important. Okay, because it is removing all these kind of issues by creating an isolated environment. Okay, now this container, I mean, if you have various kind of technology stacks and then various kind of hardware, using this container makes it independent of hardware and software. Okay. So it will give you an environment where you can install any package, anything, whatever is necessary for your application. And I mean, it would run on any kind of hardware. Of course, the basic memory, basic power, the CPU, that will be there. But other than that, if your application is running in a container, then you can be sure that this can run on any platform. Okay. So this makes it platform independent. This makes it hardware independent. This makes it software independent. All the dependencies you can bring inside the container and it will run. Okay. So this is the overall idea about the container. Okay. Once we go and run it, then we'll see exactly how it happens. Okay. So some of the things why developer or Devops specific here, it gives a clean, safe, hygienic, and portable runtime environment for your application. Okay. No worries about machine dependency, packages, and other pain points during subsequent deployments. Okay, so run each app its own isolated container, so you can run various versions of libraries and other dependencies for each app without worry. Okay. So like this one, we talked about this Jenkins and other things, right? Now just think about if you can run Jenkins within a container, right? And within that container you also install Java 1.8, right? And install Jenkins. Okay, that will be just one thing. Okay. The second application that you were saying that it was using it needed Java 1.7. Virtual machine server. Yes, well, I'll come to that. But exactly, it is similar to virtual machine, but different in a lot of sense. Okay, I'll come to that and I'll compare. Okay, but now here, the, the example that we took, so Jenkins was using Java 1.8. Both these things we can put in one container. Another software which was using Java 1.7, you install the Java 1.7 in a different container. Within the container, you run that other application, okay, which needs Java also. So by this way, you are providing both on that side and on that to a specific application. Right? So you are giving two different environment to different. Now, containers can of course interact with each other. It's not that they have to be isolated, but the way they can communicate, you can monitor that, you can configure that. Okay. So all these are various kind of properties. You can go for that automated testing, integration, packaging, anything you can script, you can do with containers. Okay. It reduces, eliminates concerns about compatibility on different platforms, either your own or your customer. Okay, so see the ideal again in the utopia that I was talking about yesterday, that the best thing would be if you if going forward we can ship something along with the container. Okay, going forward, it may so happen that the industry may evolve in such a way that you would no more be shipping the application packages only. Okay, you will be shipping the whole container, right? Because then it is guaranteed that your this thing will work because you are not only giving package, you are giving the whole environment. So if it is running on your servers, it will be running on client server as well because nothing is changing. Okay, maybe only the hardware and the location of this is changing. But since it is hardware independent, so it will run on any kind of it. Okay, so so this is mainly for now, but used for automated testing, integration testing. Frankly speaking, in the production environment, there are only few companies which are using that in production environment. But that's also because the Docker, the whole community, open source community is there, which is developing new features for Docker every day. Okay, so it is in that phase. Okay, so maybe in few years it will get stabilized and a lot of people will start. So it is basically Docker's phenomena is not that much in Indian market as far as I can see. Uh, because see, Docker is more relevant when you are a product based company. Okay? Indian industry is more of majority of it is service based industry. Right? So they have to basically go as per client's demand, right? So if the client demands to offer, then you will do. Okay, otherwise you may not do that. Right? But in the US market, if you see, they have a lot of new startups coming up which are purely giving content, container services. There are companies who are launching their product, in Docker itself. Okay, they are starting, but they are using them, okay, because of the flexibility that it gives you and the reliability that it gives you that the code will run. Okay, so maybe in few years down the line we will have similar because once it becomes mainstream in US or Western market, the client themselves will be demanding that okay, give my next version in a container environment, right? So it has a huge scope. These technologies like Dockers, containers, microservice-based architecture, and cloud, right? So all these are basically complementary. Right? DevOps, along with cloud, along with microservice-based architecture, and containers. There is another thing called serverless architecture. All these things are fueling each other. Serverless architecture. Serverless architecture basically means that all these cloud service providers, they are giving you flexibility that you don't have to worry about the servers. You have done a code, or if you have written a code for an application, just give me the code, okay, and give me event when to run it. Okay, when to run it, you tell me, right, and give me the code. Tell me the language in which you have written. I'll figure out the rest of it. Cloud service providers are saying it. Okay, you don't. The companies don't need to bother about the hardware part. Okay, so when that event will be triggered, that particular application will run. as soon as your application exits, uh, hardware would be released. Okay, so all this, Google Cloud has GCF, Google Cloud Function. Azure has Azure Function. This AWS has Lambda services. So all these things are basically during this server. Azure Azure Function. The name itself is Azure Function. Okay, so these are various services provided cloud, which are serverless based web services. Okay, so you don't have to configure that I need a server which has 1 GB RAM on the. Okay, so it will figure out by itself. Okay, and why they are using it? Because they can now, all the hardware is theirs, right? So they can better optimize their hardware according to the need of the application. Right? So this is the way forward. So all these containers, they are very uh, easy to work with in this environment, serverless environment, microservice-based environment. Right? So if you remember yesterday's example that I gave for Uber application, right? Microservice-based application. Now you can, all those components may be running in a particular container. Right? That container, you can create multiple containers, right? Going forward, we'll see exactly how these things are complementary with each other. But the thing is, all these technologies that we're talking about here, microservices, architecture, cloud, DevOps, continuous integration, all these things are, fueling the whole market, and it is going to the next level. Okay. So it has G for zero penalty containers to deploy services. So this is like a virtual machine container, but without the overhead of virtual machine. Okay. Have you ever installed virtual machine on your system? You have done, right? How much time it takes to install a virtual machine? Normally. Okay, so this might have done first, right? 15 to 20 minutes in installing it, and then when you run it, when you configure it appropriately, right? This will take 14 minutes, right? Give or take, what I have experienced is 1.5 hours of time, right? Uh, Maybe that's machine dependent as well, right? So, and the size of the virtual machine would also be huge, right? 4 or 5 GB or something like that. Okay, then it depends on the size and data. Exactly, it's depend on this. So all these are very, various overheads. When you are installing virtual machine on your computer, you are basically doing it maybe for the next 30 days, right, or maybe even years, right? It's kind of, stable installment that you are doing. Okay. So how many virtual machines can you run on your system? Maybe 4 or 5 at max, right? In a simple configuration, right? Because everything would need hardware space, CPU, clock, right? All those things. Now, container is giving you the same functionality that your virtual machine is giving, right? But with a very little overhead. Okay, you can run hundreds of containers on your laptop. Hundreds of containers. Okay, each container would have similar kind of capability that your virtual machines have. Okay, so, and we'll see why so much. It takes a very little space on the computer. It takes a very little um, CPU speed and all. Okay, so you can, and just running a container would be like 2 minutes of task. Okay, if you already have installed Docker, then running a container would be just matter of seconds basically. Okay. And you can put just copy your application into that container and you can start running it. Once you are expert at it, it will become just matter of minutes actually. To create the same environment that you create in virtual machine using 45 minutes that you are saying, it will take only few minutes. Okay, so this is the flexibility that container is providing. Okay, why DevOps care? Now that is from developers point of view. From DevOps point of view, you configure it once and you can run anything. Okay, so make the entire life cycle more efficient, consistent, and repeatable. So container, when I say, it is just the building block in the whole environment. Okay. In the real life, you would be working with hundreds of containers at a time. All these containers could be of different type. Okay, so you have multiple containers doing multiple tasks, right? Doing multiple jobs, and all of multiple containers coming together to accomplish a single task, right? That is your whole scenario in which you work. Okay, so um, so you can, I mean, these containers are first of all very cheap. You can, since it doesn't take much to create a container, so you can easily delete a container, right, and create another one. Okay, so you don't have to think about that. Okay, if I delete the container, I have to create another one again. It can take much time. No. It's very cheap. You can keep on creating container. You can keep on deleting container, right? It is very flexible in that manner. So it, uh, okay. So all these things, I'll show you this slide. Okay, let's go through it. Okay. So then we have technical systems that we can develop development, test, production, customer environments, support segregation of duties. That is, you can create a container for different components, and all of them can talk to each other. Now this is important because the containers are so lightweight, address significant performance, cost, deployment, and portability issues. Normally, it is normally associated with virtual machines. Okay? You cannot ship a virtual machine along with your application, right? But you can do that with your containers. Okay. So, so coming back to coming back to this container versus virtual machines. So this is what the difference looks like. In a virtual machine, this is about virtual machine. This is about container. In virtual machine, you have underlying hardware, server. Over that, you will be having host operating system. Okay, and then there will be hypervisor running over it. Okay, then you have may have various virtual machines. So there, in this case, we have three virtual machines installed. In a virtual machine, you again here have a guest operating system. Okay. Um, then over that guest operating system, you have to install an application. Okay. Now there could be various kind of binaries and libraries which are basically dependency packages. Okay, so you have to put all these binary and library for this virtual machine is very much isolated with other virtual machines. Okay, so when you are having three virtual machines, basically you have to install three separate best operating systems. Okay, and then even though the same binary and library is used here as well as here, they have to be stored separately, correct? Because they are in different virtual machine, right? So if another app is running, okay, then I mean second version, suppose this is 1.0 and this is 1.1. So even though there is a lot of similarity here, you still need to have all your binaries and libraries separately associated. Okay. Similarly here, if there is another application which is using different binaries and libraries, it needs to be very separate. Okay. In container, what happens is there is a server, then there is a host operating system. Okay. Then you directly have the required binaries and libraries. Okay. Now, of course, here under the host operating system, your Docker is one rather than hypervisor. You have a Docker host running. Okay. Using Docker host, you can you can have multiple containers over it. They don't need a guest operating system. They just need the binaries and libraries of what they need. Suppose this guest OSS, suppose this whole thing is Red Hat Linux guest operating system. Now you have to run Debian Linux system, okay, over this. So what they will do is you don't have to install the whole Debian operating system. The whole thing you don't need. Okay? You just have the essential binary and libraries of the Debian system. Get it here. Your Docker host will help you bringing on the from the internet itself. And then you can just over that image, the basic binaries and libraries, you can have your application code installed there. Okay. Now, if here you see it was application 1.0, it was 1.1, right? Different versions of the same application. If anything like that happens here, then they can basically share the meaning, what is common, right? So most of the things they would be able to share, right? They won't be changing any of it, but whatever is shareable, they will share, and that goes for any other application. Okay, so they are isolated here as well, right? But that doesn't mean they won't be sharing the resources. Okay, so this is why this has become so lightweight, right? Now here, if you have to run 100 apps, 100 applications, okay, you have to create 100 different virtual machines. Right? Whereas here, if you need to do the same thing, you can have hundreds of apps, all of them using the same resources. So basically, the memory requirement that you have, it is very less in terms of in case of containers. The same because the same memory location is being used, same binary and libraries are being used by all the containers, and still they are isolated from each other. Okay, due to these kind of design things, uh, it has been very containers has been very lightweight in terms of resources. Okay, now we can come to this. So why to use containers? You can run everywhere. Uh, Whenever the Unix version is more than 62, you can run it. Okay, regardless of host distribution. So it is running on any kind of Unix operating system. But before that, I'll tell you that till recently it has not been possible to have the containers on Windows kind of environment. Okay, uh, a lot of work is going on to make the Windows as well specific, you know, um, sometime with this container kind of thing. But mostly till now we are working only with Linux and Linux based container, Unix based environment. So so that is why it's saying kernel version actually. So kernel means Unix kernel. Okay. So container and host architecture must match. Okay. So um, run anything if it can run on the host, it can run on the container. If it can run on the Linux kernel, it can run. Okay. If you don't have that much of interoperability issues, So, what exactly is the container? On a high level, it is lightweight virtual machine. If you have to just explain it to someone, just say lightweight virtual machine. Okay, it has its own processor space. So within a container, if you run commands like ps, okay, it gives you all the processes running in the system. Then it will give only those processes which are running within the container. It won't give you the information about the underlying operating system which is there. Okay, so all the Unix commands etc. you can run, but the information that you get, that will be what is there within the container. Yes. So it has its own network interface. So every container you may assign with its own IP address. Okay, you can have a network of containers in the same way that you have LAN. Okay, because everything has its own interface address. It can have its own private IP address, and it can have even its port, right? So different containers have different port and interface. So it can think of them like a server once they are fully fledged. Okay. So they have their own SBIN init kind of directory structure that your normal Unix have. Within every container, you can find these kind of directory structures, right? So it is easy for you to in configuration in having Unix like environment within every container. Okay, so low level, again, if you want to go further inside, basically containers. No, I'll defy what I said actually. Okay, I said container were created by Docker. That's a bit simplistic statement. Because see, containers were already there from way back in 80s. Okay, when Unix was created, uh, there was something called LXC, okay, lightweight container. Okay, um, and they were using something called C groups. Okay, so these technologies were there already. Okay, all the technologies that were needed for containers, it was already there. Okay, but it was not so easy to create a container. Okay, a lot of technical knowledge you need to have to basically design the container and work with that. Okay. Now, what Docker as a company did, that it simplified everything. Okay, it gave you Docker software using which you can create container in no time. But basically, it was also using the same thing, the inbuilt feature of LXC and C group. Okay, so now they have their own. What I heard is their. I mean, they are no more dependent on just LXC and C group. But this is how they started at least. So at low level, it is change root, switch root is Unix uh, command actually on asteroids. That is, it can also not have its own SBIN in it. Okay, containers are basically isolated process. So if you see from the operating system's perspective, every Docker container is nothing but a single process. Okay, but you can run processes inside the processes, inside the container. So within one process, container process, you can have multiple processes. Okay. So basically on low level, it is container is nothing but just an extra process. Okay. But the thing is, this process is giving you the whole environment. So you can go inside it and you know, install several other processes as well. Okay. It shares kernel with the host. Okay, why it has become so lightweight? Because see, even if you bring Debian, okay, on the Red Hat guest OS, you want to create a Debian environment. Okay, then also there are so many libraries and languages that are common between Debian and Red. Okay, so it is using the libraries and languages of guest operating system as much as it can. Okay, so you don't need any hypervisor here. You don't these are called basically HVM or PV. There are two different kind of hypervisors are there. You find it even in when you create EC2 instances, right? Then you'll see a lot of these things, HVM and PV. Okay. So that is not an emulation. It is a different process. So why dockers are lightweight now you must have understood, right? Here you have to have the whole guest operating system. Here you don't need because it is using the libraries and binaries of the guest operating system. But since it is generally binaries and libraries are open in a read-only mode, so it will never change that binaries and libraries, right? So I mean, if I have hundred of users who are just reading, binary number, that is the harm in sharing it, right? Problem it may have happened if they are going to change, okay? But that they don't do for shareable library and binaries. Okay. So, so if you're in fact, what happens is what they're telling is that if you have one container, okay, uh, creating a container, running it, maybe suppose it is taking say 100 MB of space. Okay, that doesn't mean that if you get another container, it will again take 100 MB of space. Okay, because it will be reusing the binaries library and again, you know, common images. Okay, so even if you're running second container, that may be taking 10 MB extra space, right? So one container is running in 100 MB space. So two containers are running in 110 MB space. Third container you bring, it become 130 MB, right? So only the differentials are getting multiplied. That is giving you the power that you can run hundreds of container on your own network, right, with their same container. In fact, even for different type of container, you will still need this 100 into 100 MB. Okay, just giving you a case. Okay, so in that way,
In this case, the containers architecture and that of host operating system architecture should be same.
should not exactly be the same. If it is similar, it's more beneficial. That's why I'm saying it is the current containers. They are basically for Linux only. So if you are seeing, see, every Linux is underlying using Linux code. A lot of Linux code is being taken. Now every Linux has a basic version, okay, plus some more features. How does Red Hat Linux is different from Debian? Okay. Debian has some other features implemented in some other way. Red Hat has some other feature implemented in some other way. Right? But when you are running an application of your own, you just need very basic functionality of that, right? Whether it's Red Hat or Debian. So you are just concerned of those documents, right? So yes, what you said that architecture should be same, of course. Okay. But if it is Unix, there still a lot of things are same. So container exploits this similarity between various containers. If it is different, okay, then it can bring on those additional libraries and like no issue with that. Okay.
Automatically building or
Automatically it will do. Okay. You'll see that most of the things are automated. Okay. But of course, yeah, you may have to bring something separately. Depends on your application, depends on that dependency. Okay. Okay. So this another main feature of container is that suppose on you had a host operating system as Red Hat Linux. You brought in a Debian image over and over there. Okay, and then you install some more packages. Okay, so this whole thing, okay, this top layer of the desktop operating system, which is Debian, plus your own packages, you can repackage it. Okay, you can make package including this Debian plus your own package, and very easily you can distribute it as your customized Debian operating system. Okay, very easy. You just need to run few commands, and it will make a package having the main system plus whatever applications you install. Okay, it's just matter of 2 3 commands. Okay, we'll see how to do that. So that makes a modified app. So the next person, okay, he don't even need to do all the things that you do, right? So this is you are creating something which is repeatable, right? Reusable and repeatable. So that is how um, again ultimately everything is about resource optimization, right? Whether it's time resource or human resource. So you create one and that can be used by so many other people. Okay, that is where this is becoming very very resource efficient. So going back to slide, now things will make a bit more sense, right? If you again go to the definition of continuous interpreter, but coming back to uh, container architecture, we do go through all these slides and see it. Now, suppose now here we need to see the components of a Docker container. Okay. So mainly there are three components. Okay, one and most important one is your Docker host. Okay. So this is your client, Docker client we call it. Docker client may be running on your own desktop. Okay.
Docker client means that you are that application, Docker application, you will install
A
the
part of Docker, a part of Docker application may be running on your own system. Again, it's like using Jenkins master client kind of thing, right? So master and other nodes can run on the same server or maybe even in different server. Okay. Maybe you are remotely accessing the Docker server. So basically, when you say Docker server, mainly we are talking about Docker host. Okay. So the client could be accessing these things remotely or internet or something. Okay. So now on a Docker server, there is a host operating system running at runtime, right? Over the host operating system, when you install Docker, what you are basically installing is you are installing a Docker daemon. Okay, Docker daemon is a process, right? Which will always be running. Okay, when you say service Docker start, basically you are starting a Docker daemon on your server. Okay? Now there is a so when you are running a container, that container process would be running on Docker host. Okay. Now there's something called Docker registry. Now Docker registry is basically a repository of all the images, right? When you're saying, suppose you need Ubuntu image, okay? So Ubuntu image, the soft copy of the whole operating system is kept at Docker registry. So you have a site called dockerhub.com. Okay. For the most part, this is your um, Docker registry. So this particular website works as your Docker registry. Most so like within, if you're working in an organization, your organization can have its own Docker registry within your line, within the VPN. So it may not have access to, so outsiders may not have access to that. Okay. This, if you have understood GitHub.com, right, how that works, it is exactly similar. Okay. The only difference is in GitHub.com you are pushing the code, right? In dockerhub.com, it is basically you are pushing the image, that is the compiled code, and along with some other packaging and all. You are putting that thing on the dockerhub.com, right? Okay, right? So here also there are so many like in GitHub. You have so many open source codes already available, right? All those things projects are in open source. You can get it from GitHub. Okay, you can search for that and get the exact source code of all the things like Unix, Linux, and wherever the source code is open, you can get it from GitHub. Similarly, on Docker Hub platform, you can get all these open source things like Ubuntu, CentOS, the basic images you can find from this particular website. So this particular website is working as a Docker registry. Okay. So on this Docker registry, there will be a lot of images already hosted. Okay. On your server, we will be creating our EC2 instance as a Docker host. Okay. And then I can just run few commands which will which will pull the corresponding image from Docker registry. Okay. See, creating a Ubuntu virtual machine over our Amazon Linux, right? Our EC2 instance on Amazon Linux. I need to suppose create an Ubuntu environment over this. Okay. I literally need to once our Docker is installed. Okay. I literally need to run one command, which is Docker run minus IT Ubuntu. That's it. Okay. This will go to the Docker registry, bring the latest image of the Ubuntu, download it on your system, and run it. And maybe if you have used appropriate options, then you will jump to the inside of the content. All of this is in the okay. Now imagine the same thing what you do in virtual machine, right? So containers making your life so easy. Okay, it is lightweight. You can do all these things in just one command. Okay. Anytime when you are running commands, let's say Docker run 2.2, right? I'll be firing it from the client. Okay. The client goes. So this is how it basically works. When I'm running Docker commands, suppose I this Docker run, then it is going to the Docker host, okay, from this laptop to went to the EC2 steps, okay, our machine, and then uh, there the Docker daemon, which is a constantly running background process, it will receive your request and it will search, okay, it will search if you have done Docker run Ubuntu, it will search locally. Do I have an Ubuntu image already? If it has, it will just run it, okay, execute it. If it doesn't have, then it will contact to this docker.com, which is our Docker registry. Okay. It will bring that image, download it, and then execute it.
Suppose we will make our EC2 instance in a Docker. Then our client system also need to install Docker to interact with
Docker client should be there on your client system on this particular system. Okay, Docker client. So yes, I mean it's not very heavy.
yeah.
You just install Docker. Normally, will be when you install Docker, it will install the necessary things for Docker host as well as Docker client. So if you run it from the client, you are basically connected to this Docker host. Okay? Then you can run it from there.
Connecting to
In our case, again, we will be running the same thing. We will just log into our EC2 instance, and that will be working for us as a Docker client as well as Docker host. Okay. But the process, flow of the process will be same. Okay. Our
Means
terminal.
if I from our local system, if I connect to the local host, which is running on these two instance, so then through PuTTY I have to connect.
You can, by the way, run. There must be Docker client even for Windows.
Yeah, the client is there.
For Windows as well. So if you do that, you can directly do from your PowerShell. then of course this would be a bit lengthy, right? Because you have to connect to that host and then run the command every time. Right? Or the shortest way is just connect to this Docker host, right? To Putty or something, and start running your commands. Okay. So basically, it's
So
logically
here in the Docker and the container, Docker, what is Docker and container?
that's what I
Container,
said. It's like Xerox and photocopy,
there is
right?
Docker. Um, Docker is the root one which creates which when you will install that Docker. Docker is an application.
Docker,
Container is a
yes,
VM.
exactly,
Container
exactly.
is a VM.
Containers, exactly. Very well. Okay. So within, when I say Docker, install Docker, you are installing the whole environment. When I say you are running a container, you are basically running particular
Like this, if
container.
you take an example of hypervisor, hypervisor in application. Within that, we create VM that is
Yes, yes. So you can, if you want to compare it to VM, then you can compare this Docker application with the hypervisor. Okay,
yes.
you can compare it. They are not
Compare
exactly same,
exactly same.
but this is analogy.
Functionally different, but the
Exactly.
theoretically.
Okay. So this is how it basically logically connected. Now, having said that, do remember that this registry why I am not showing here dockerhub.com, because dockerhub.com is just one place. The same that we have github.com, right? But you also have bitbucket.org in case of source code. That's a different
And the
source
Kubernetes
code.
also this concept only.
Yes, now I'll come to that when Kubernetes comes into picture. See this, as I said, this kind of containers are created by Docker and Docker, two separate companies. Google created its own containers. They are called K8s.
Yeah,
Eights, eight in number.
yeah.
Okay. Kubernetes basically from there. So ultimately, if you go further deeper into Docker, ultimately Docker provides you a whole setup, okay, about container management, right? So in a full-fledged microservice-based application, you may be running hundreds of containers, right? A group of the containers running a particular task, right? So see, creating a container is very cheap, but managing all these hundreds and thousands of containers, that becomes again a very tedious task. Okay? So Kubernetes as well as Docker provide you a management system so that you can monitor, you can manage these containers. Okay, so if your application is using hundreds of containers, then how to manage this container, how to assign each container a certain task, what if the task gets completed and the container is idle, it's better to delete it. Right? So load balancing, you know, we call it service discovery, that is which job should go to which container. So that is a whole container management task. So Kubernetes is a container management system, right? Docker also provides you container management system. So there is, if you just say that building a container, I know how to build it. So those things we will go into details. How to create a container, how to create images, all those things in this course. Okay. So, but
Means Kubernetes is a container management application.
container management system, yes. So Kubernetes basically was developed by Google. Now they made it open source. Okay. This one is from Docker. From cloud perspective, you see, AWS is using Docker actually. They have this ECS, EC2 container service. If you see under
Container
compute, just under EC2 you see ECS, right? EC2 container service is in the background using Docker. So AWS and Docker has collaborated to create the ECS. ECS is a container management service. Okay. Similar to Kubernetes. So you have the option, you can use go for Kubernetes or you can go for ECS. or you can go for premium products of Docker, which are again management system, container management system.
Okay, paid versions.
If you yeah, there are paid versions. If you are again, if you are technically very sound and you have the capability to learn, then you don't need any of those Docker management systems. You can create your own scripts to monitor those containers. But these are basically built-in, gives you a lot more flexibility, right? So okay, so rest of the things from tomorrow will actually start. I'm sorry, from the next session. I'll just hold on to this thought. Okay, I don't want to rush. Okay, so just to read, I'll send you some Docker. This um, history materials. You just go through it. You have the high level knowledge, right? As of now. So you just go through it. Okay, you do study for this whole week, and then in the next week we'll start with practical aspect. Okay, so if I go for the practical, it will be very heavy actually.